On June 24, 2021, a 12-story condo near Miami collapsed in a matter of seconds, killing many residents. It is one of the deadliest building collapses in U.S. history. This is, unfortunately, not an isolated case of a building failing catastrophically. The Sampoong department store collapse in South Korea in 1995 is among the deadliest building failures. The building collapsed due to several structural failures, killing more than 500 people and injuring over 937 more. Since they are designed and built to stand the test of time, buildings don't fail frequently. So what causes buildings to collapse catastrophically? And are there any warning signs before a building fails suddenly? Overloading. Buildings are designed to support a certain maximum load. A building can collapse if there's more weight on a portion of it than the structure is designed to support. This can happen when the material's strength deteriorates over time. Overloading was one of the causes of a factory collapse in Dhaka, Bangladesh in 2013, in which an 8-story commercial building failed, killing at least 1,132 people. Material deterioration. Chemical changes in materials such as rust burst can cause buildings to collapse. Steel is used alongside concrete to add strength to buildings. But rusting steel can expand up to 6 to 7 times its original thickness. When embedded in concrete, this expansion can crack the surrounding structure. Cracks appear. Then rain and frost cause the cracks to widen, rendering the building unsafe. Ground settling. Buildings don't have to be very old to begin sinking into the ground. When a structure is built on unstable land, such as soft soil or marshland, the foundation can begin to sink shortly after construction, and this gets worse with time. When a foundation fails, the building collapses from the bottom. In a high-rise building, this results in a pancake effect, where the upper floors slam down on top of the collapsed foundation. Design flaws. Buildings are typically designed with redundancies or alternative load paths. If one section of the structure fails or weakens to the point where it can no longer hold the building's weight, that load is redistributed to another section. Designs that lack such redundancies can lead to devastating failures of the entire structure. Natural disasters. A building may also collapse due to natural disasters, such as earthquakes, fires, or hurricanes. Earthquakes cause movement at the building's foundation by generating waves across the ground. This energy is transferred into the building's structure. If the structure is unable to absorb this energy, the building can fail. Buildings can be designed to withstand an earthquake. Shock absorbers or seismic dampers are used to make buildings earthquake resistant. These dampers absorb the destructive energy, protecting the building from collapsing. A base isolation system can also aid in the survival of a structure after an earthquake. This consists of a collection of structural elements that separate the superstructure and substructure. During an earthquake, the substructure moves, but the building stays still. A seismic invisibility cloak is another technique for making a building earthquake resistant. This involves digging cylindrical pits or using a series of concentric plastic and concrete rings around the foundation of a building. As the seismic waves approach, the rings scatter the incoming waves, causing them to interfere with each other and cancel out. Engineers are constantly testing new design theories and materials to produce buildings that can withstand the worst natural disasters. Researchers are working on metal foams that can be fit into joints of a building to absorb energy and prevent earthquake damage. Self-healing materials that could repair cracks in the structure or foundation of a building are also being explored. Such advancements will assist in the construction of environmentally sustainable structures.